This is example 7 of the Fourier series. We are given a function of time t, which is given to t for t between 0 and 1 including 0, and is 0 for t between 1 and 2 including 1. And the period of the function is 2 because f of t plus 2 is equal to f of t. So the period of the function is 2. We are going to find the Fourier series of ft up to including the third harmonic. The meaning of third harmonic is what? It means we want to get the value of A0, A1, A2, A3, B1, B2, and B3. Now, before we do a calculation, let's try to visualize the graph first. The graph is actually consists of t for t between 0 and 1. And if you draw the graph when t equals 0, the point is at the origin, t equals 0, f equal to 0. It's a solid circle. And t equal to 1 or near 1, actually, the function is also near 1. So this is a open circle here because it's not exactly 1, but near 1. There's a t here. And then for 1 to 2, the function is 0. So this is a solid circle here. T equal to 1 is solid 0. Then the 2. Now, this pattern will repeat. Okay, pattern in what? Pattern in here. This pattern will repeat for a period, since the period is 2 here. So you can continue to draw solid here, circle. Okay, then open circle here. The graph repeat itself like this. Then open, close the circle, then again. So this on the repeat on the right hand side, and you can also repeat on the left hand side as well. So if you draw your like this, period is 2 here. So this is solid circle, then open circle, then solid circle here. So this is how the function behave. Notice that although the graph, the shape is the same, but these equations are not the same. For example, although we know that this is 0, right? However, this is t minus 2, okay? Because when t equal to 2, the value of function is 0. When t equal to almost 3, the value of function is 1. And for example, this is t plus 2, right? Although the graph is almost identical, but actually the formula are different. But anyway, we are interested in the center, this piece here, where we do our calculation. Okay, this is the part where we compute the Fourier series based on this, where we'll see later how to do the calculation. Now that we are ready to calculate the Fourier coefficient A0. First, notice that the period of this periodic function t is equal to 2 seconds. Therefore, omega 0, which is 2 pi over t, is equal to 2 pi over 2 is pi. which is the angular frequency. Now the formula for A0 is equal to 1 over t, and then integrate from k to k plus t f of t dt. Now we have put k equal to 0 now, so we are integrating 1 over 2 from 0 to 2 because t is equal to 2 here. Integrate the ft dt. However, ft consists of two parts. One is from 0 to 1. Ft is actually equal to t. Right? From 0 to 1, ft is actually equal to t. And from 1 to 2, ft is actually 0. Of course, we know that integrate 0 is 0. So we only have integrate of t, which is t squared over 2, from t equal to 0 to t equal to 1. The second term is 0 anyway. So substituting the limit, you get half times half, which is 1/4 now. And that is the value of A0. Next, we are going to find out AN, which is equal to 2 over t, integration of k to k plus t, f of t, cosine n omega 0 t dt. And we know that the period t is equal to 2 from our diagram. And then we also know that we can take k equal to 0, and omega 0 we calculated earlier is equal to pi. Right? So let me write properly. So omega 0 is equal to pi here. Therefore, we are looking for integral of 2 over 2, period is 2 here, integrate from 0 to 2 f of t cosine n pi t dt. However, we know that 2 over 2 is 1, so this integration of 0 to 2 ft cosine n pi t dt. However, the integral can be split up into two terms. One of them is between 0 to 1. We know that ft is equal to t, right? Ft is equal to t. So this is actually t cosine n pi t dt when you integrate from 0 to 1, and then plus another term, integrate from 1 to 2. The function ft is equal to 0, okay, as indicated here. So this is 0 times cosine n pi t dt. Anyway, integration of 0 is 0 here, right? So we end up with integration of 0 to 1 t cosine n pi t dt. To do this integration, we need integration by part. You can follow LIATE. So we have A for t and trigo, A for the term t and trigo for the cosine n pi t. So now let's do integration by part. You have u, which is t here. dv is cosine n pi t. And you're going to do a shortcut integration by part now. First, on the left side, you do differentiation. On the right side, you do integration. So differentiate t, you get 1, and differentiate 1, you get 0. On the right side, integrate cosine n pi t, you get sine n pi t divided by n pi. And then integrate sine, now you get negative cosine now, n pi t divided by n pi again. So you get n squared pi squared. And then you draw downwards arrow starting from t. So the downward arrows have a sign. You have positive sign first, followed by a negative sign. So from here, your an is equal to 1 over n pi t sine n pi t minus come plus already, so we get plus cosine n pi t over n squared pi squared. And you put in a limit from t equal to 0 to t equal to 1. So when you put t equal to 1, you get 1 over n pi sine n pi plus cosine n pi over n squared pi squared. Right? When you put t equal to 1 into the limit, so this is the first term, and then you subtract the limit when t equal to 0. Alright, so t equal to 0 now, so this is 0. So the first term is 0 because 0 times sine 0 is still get 0. So first term, you get 0. Second term, when t equal to 0, you cosine 0 over n squared pi squared. Now, here is a common knowledge you should know. What is actually the value of sine n pi? For example, sine pi, sine 2 pi, sine 3 pi, sine 4 pi. What do you get? The answer is 0. Okay, sine pi, sine 2 pi, sine 3 pi, answer is 0. What is the answer for cosine 0? Cosine 0 is 1. How about cosine n pi? We'll just leave it there. Later on we'll figure out. So using this information, alright, so we know that this is 0 here, this is 1 here. So an is equal to 1 over n squared pi squared times cosine n pi minus 1. Right? So this is the final answer for an. And then we're going to find out what is an later on, one by one, the first 3 terms. Okay, let's find the value of an now. For n equal to 1, a1 is equal to 1 over 1 square pi square cosine pi minus 1. Alright, so 1 square is 1, pi square is pi square. Now, what is cosine pi? Cosine pi is equal to minus 1. So, this is actually minus 2 over pi square. Then, what is A2 now? Put n equal to 2 now. 2 square, pi square, and then you have cosine 2 pi minus 1. Now, 2 square is 4, pi square, just leave it pi square here. Cosine 2 pi is what? Cosine 2 pi is 1. So, this is 0. A3, n square, n is 3 now, 3 square, pi square, then cosine 3 pi minus 1. Now, 3 square is 9, pi square, leave it before, and cosine 3 pi is minus 1. So, this is equal to minus 2 over 9 pi square. If exclude 0, you can find that the absolute value of an is getting smaller and smaller. And what else you can know? Okay, one of the property is nice to know is cosine n pi is actually equal to minus 1 power n. You can check that when n equal to 1, you get when n equal to 1, you get negative 1. When n equal to 2, you get 1. So this is about an, the first 3 terms. Next, we are going to find bn now. Here, bn we have period t is equal to 2, right? From here to here, the period is 2 here. And then k we can take 0. And then omega 0, we calculate earlier, is 2 pi over t, which is pi. So put this in, we get bn equal to 2 over 2 k 0, k plus t is 2, ft sine n pi t dt, which is equal to integrate from 0 to 2 ft sine n pi t dt. Now, this integral can be split into 2 pieces. One of them is from 0 to 1. From 0 to 1, the function ft is equal to t. So, this is equal to t sine n pi t dt. And then from 1 to 2, the function ft is equal to 0. So this is 0 times sine n pi t dt. We know that integrate 0 is 0, so this one you don't need to worry. Okay, so this is 0 here, don't need to worry here. So we are actually integrating t sine n pi t dt. T, and we need to do integration by part again. So followed by integration by part, you will follow this LIATE, LIATE. So A is the t, and then t trigo equals sine n pi t. Okay, we are now going to find out what is Bn look like. So following integration by part, you have t on the first column and sine n pi t in the second column, where the left column I differentiate and the right column I integrate. using integration by part shortcut. So when you differentiate t, you get 1. When you differentiate 1, you get 0. On the other hand, when you integrate sine m pi t, you get negative cosine m pi t over m pi. And then when you integrate cosine m pi t, you get sine m pi t. So you get minus sine m pi t divided by m pi again. So you get n squared pi squared. Then you draw the downward arrow. This downward arrow has sign. Start with positive and then negative. Alright, the rest no more is not relevant anymore because multiplied by 0. So Bn is equal to minus t cosine m pi t over m pi plus now, minus is plus now, sine m pi t over n squared pi squared, and t from 0 to 1. Okay, now we put in t equal to 1 inside, right? T equal to 1 inside now. So you get minus cosine m pi over m pi plus sine m pi over n squared pi squared. This is for t equal to 1. Then put in t equal to 0 now. Alright, so you'll find that the second term, when t equals 0, the second term get 0 first, and then when I put t equals 0, get sine 0 over n squared pi squared. As I mentioned earlier, what is actually sine 0? Sine 0 is 0. What is actually sine m pi? We have seen earlier, sine m pi is also 0. It's also 0. Okay, for sine pi, sine 2 pi, sine 3 pi. And what is cosine m pi? We'll leave it first. So this is equal to, alright, 0 here. This is 0 here. So Bn is actually minus cosine m pi over m pi. Now, we are ready to find B1, B2, B3. So what is B1 equal to? So B1 is equal to minus cosine n equal to 1 now, so pi, n is equal to 1 is pi again. So now what is cosine pi? We know that just now cosine m pi is equal to minus 1 power n. So cosine m pi is actually minus 1 power n, so cosine pi is actually minus 1. So minus 1 over pi is actually 1 over pi. What is B2 now? B2 is minus, n is 2 now, 2 pi over 2 pi here. Now cosine 2 pi is actually 1. So this is actually minus 1 over 2 pi. Then what is B3 now? What is B3 now? B3 is equal to minus cosine 3 pi over 3 pi. Now cosine 3 pi is minus 1. Okay, so we get minus 1 again over 3 pi. So that is equal to 1 over 3 pi. Again, you notice the value of Pn. In terms of absolute value, it's getting smaller and smaller. Finally, we put everything together into the Fourier series. We have omega 0 equal to pi, a0 is 1/4, a1 is minus 2 over pi square, a2 0, a3 is minus 2 over 9 pi square, whereas b1 is 1 over pi, b2 is minus 2 over 2, minus 1 over 2 pi, b2 is minus 1 over 2 pi, and b3 is 1 over 3 pi. So put it in now, the function ft. Just concentrate on a first. So a0 is 1/4 plus, now for a1 is minus 2 over pi square, minus 2 over pi square, cosine, n is 1 now, omega 0 is pi, so this is the first term. Then next term is a2. a2 happen to be 0, so don't need to write a2 because anything times 0 is 0. Then a3 is minus 2 over 9 pi square, so cosine 3 omega 0 is pi t. So you write down the first three terms of an now, excluding a0. Then let's write down bn. First one is b1. b1 is 1 over pi. Then sine n is 1 now. Pi omega 0 is pi. So this is b1 sine omega 0 t. Then b2 is minus 1 over 2 pi sine 2 pi t now, and it's 2. And then finally b3 is 1 over 3 pi sine 3 omega 0 is pi t, and so on. So this is how you get the terms. You can simplify it and say that okay, ft is equal to 1/4, okay, minus 2 over pi square cosine pi t, and then minus 2 over 9 pi square cosine 3 pi t, and then plus, this is a cosine series, and then a sine series, you get 1 over pi, then sine pi t minus 1 over 2 pi sine 2 pi t, and then plus 1 over 3 pi sine 3 pi t. Right? So anyway, this is infinite series. It just happen to write down the first three term of an, and then the first three term of bn. And that finishes example 7.